Attendees are in listen-only mode.
Hi everyone, welcome to our April Journal of Statistics Education webinar. My name is Michelle Everson. I'm from the University of Minnesota, and I'm the current editor of JSE. And we're really delighted today to have Amy Froelich from Iowa State University with us. She'll be talking about an article that was published in our July 2013 issue called Does Eye Color Depend on Gender? So this was one of our data sets and stories submissions. And in a moment I'll hand things over to Amy, but I just want to remind you about how the webinars work. So Amy will be sharing her work for roughly about 15 or 20 minutes, and then we'll open things up for questions. If you have questions along the way, please type them in the questions room, and I can ask those to Amy when we end the webinar. Or toward the end of the webinar, you can also raise your hand and I can unmute you and you can talk to Amy directly. So with that said, I'm going to hand things over now to Amy. Go ahead, Amy.
It appears that Amy's having problems with her connection.
Okay, yeah, I didn't know if that was just me or...
No, I don't hear either.
Okay, please be patient, everyone. We're trying to get Amy back on the line. There seems to be some audio issues. So as you're waiting, you might go to the JSE website and look at Amy's paper. If you have it in front of you, that might spark some questions that you can ask Amy later on.
Amy, we can't hear you. Can you hear us? Respond in the chat window.
Thank you for your patience, everyone, as we try to figure this out. We might need to change Amy's microphone. Are you there, Amy?
I'm here.
Okay, now we can hear you.
Oh, okay.
Could you
Sorry about that.
Start at the beginning. Sorry, we lost your audio.
Okay, so are we good now?
I think so.
We can hear you. Go ahead.
Okay, perfect. So we'll just pretend like the last couple minutes didn't count. So the title of the paper is Does Eye Color Depend on Gender? It might depend on how you ask. Here is the information about the Datasets and Stories article. It was co-written by my colleague here at Iowa State, Bob Stevenson, and it appears in the July 2013 edition. And in the PowerPoint notes, there's also a link to the article. I did have another article also in the same edition of JSE, so the end part of the link is important. Okay, so the general idea of the article is that several years back we wanted to use student data in our introductory statistics course to increase student interest and to obtain a real source of data for our class. The data set that appears in the Datasets and Stories article has been used in our introductory and our intermediate statistics courses for data analysis and for inference. And we've also used the data set in a computing course as an example of data cleaning. We used the IntroStats book by DeVoe, Volleman, and Bach in this particular course, so I thought in terms of explaining the data set, I would borrow their 5 Ws. In that the data set contains records on 2,068 Stat 101 students. And there are, in our data set, there are 15 different quantitative and categorical variables. In the data set we submitted with the article, we only included 14 because there was a variable that we didn't collect through the entire data collection period. So I'll talk about which one that is in just a minute. When we collected this was from spring 2004 through spring 2007. And of course we collected it here at Iowa State University. And again, our motivation for collecting the data was to motivate topics in both descriptive and inferential statistics. At the time, learning management systems weren't in great use, and so we actually collected the data through a survey on a website. One of our IT colleagues helped us set that up. And student names were collected, and students were given credit for completing the survey as a few homework points, basically. But their names were kept separate from the data, so the data was never connected to a student name. So here are the 15 variables that we collected. So the first slide includes variables that are basically demographic variables for the students. So we asked for gender, age, and years, height, and inches. Students struggled a little bit with the conversion to inches, so I think if we had to do this again, we would ask for the height and we would just ask for feet and inches and do the conversion ourselves. Year in school, their eye color. We asked how far in miles was their hometown away from Ames. And then we asked for their number of brothers and number of sisters. Then we asked some variables of just kind of about what they spent their time doing. So we asked them, you know, how many hours did they spend on the computer per week? Did they exercise? How many hours did they do that, et cetera? And the last variable is italicized, and this is the one that we did not include in the data set we submitted for the article, and that was birth weight. Bob actually started asking this question when he took over the data collection for Stat 101, and I think the reason he did that is both I had large babies when they were born. They were both 10 pounds, and he was also a large baby as well. So I think we were just interested, he was interested to see what that would look like. So those are the variables that we collected. And when we started looking at the data set as we were collecting the variables, we noticed some interesting things about gender and eye color. And so this formed the basis of the paper. So the student reported eye color. We had gone through and looked at different eye colors and how they were classified, and really eye colors are only classified as either blue or brown or green/hazel. And blue includes, you know, light gray all the way through dark blue. Brown is basically brown and includes very dark brown or what might look black. And then if your eyes aren't blue and your eyes aren't brown, they're considered this green-hazel color. We felt like students probably wouldn't feel comfortable with just those 3 choices, and so we wanted to give them an other category if they didn't feel like their eyes fell into one of those categories. And we were also interested to see how students would define their eyes between green or hazel. So we ended up with 5 options, and they were presented to the students in a drop-down menu. So these are the only 5 options they could choose. The other category ended up being chosen by very few students, only 42 out of the 2,068. So we went ahead and dropped that from the analysis we presented in the paper. None of the results in the paper change if you include that category. Then, of course, gender was collected, and we used that also with a drop-down menu with the 2 options, male and female. So the first thing that we do when we present the data set to our students in class is we look at and start with an analysis of the individual variables. And so we look at gender first. And you can see that in our class, there are in our data, there are more females than males. And so we ask our students, why is that? And in general with our students, they will kind of look around and they know that certain majors are required to take Stat 101 and other majors take some of our other statistics courses. And so we're very quickly able to realize that basically the majors that take Stat 101 are a little bit more female than, have more female students than male. Then we move on to the analysis of the eye colors. And you can see with the 4 eye colors, we have blue, brown, green, and hazel, and we've provided that as a bar graph. And we also talk to, or speak to this in the paper about comparing a bar graph and a pie chart with these graphs as well. So in the analysis of the eye color, you can see that blue and brown are about the same. Green and hazel are about the same. And then if you look at putting green and hazel together, those proportions of the students end up being about the same. Okay, then we move on to the contingency table, so looking at the cross-calculation of eye color with gender. And if you look at the eye color and gender, the contingency table, of course, is hard to detect if there's any patterns in the data. So then we talk about the concept of both marginal and conditional distributions. And so we have them go ahead and calculate the conditional distribution of eye color given gender. And so you can see in this table, all of these values are percentages. And we look at both brown and hazel, and notice that the percentages are fairly close to each other and fairly close to the marginal percentage for that eye color. However, for both blue and green, there are differences in the marginal, or in the conditional percentages, and then in their relationship to the marginal percentage. We also introduce a mosaic plot to our students, and so we show them the mosaic plot of the conditional distribution of eye color given gender. And so this is a visual representation of the conditional distributions that they just saw. And we notice that for male, the distribution of eye color has a larger percentage of blue than it does for female. Brown, the boxes are approximately the same height, and we see that in the similar color. In green, the female, the box is higher, so there's a larger percentage of females reporting green than males, and the hazel is approximately the same. Now, while we only give them the conditional distribution of eye color given gender, you could do the conditional distribution of gender given eye color. And so here are the conditional distributions in the contingency table. And so we see that basically the same thing as before. According to the marginal distribution, our split should be about 55-45 between the two genders, and that's what we see for brown and for hazel. But the split between the two genders is different for blue and for green. There's a larger percentage of male for blue and a larger percentage of female for green. And we can visually see that with the, excuse me, with the mosaic plot as well. And so we have our findings for both conditional distributions. And again, we only present the one, but you could present both if you wanted. Let me go back to the first finding. So if we were looking at the conditional distribution of eye color given gender, brown and hazel, similar percentages report these for the two genders. But for blue and green, there's a larger percentage of males reporting blue and a larger percentage of females reporting green. If we're looking at these conditional distribution of genders and then eye color, brown and hazel the same thing. Their distribution is similar to the overall distribution of gender. But for blue and green, the distribution for blue is tilted towards males and it's tilted towards females. So at this point, we can ask ourselves the question is that, are reported eye color and gender independent variables in our population of Stat 101 students at ISU? In order to answer this question, we need to assume that the sample is representative of the population. And this is a good discussion to have with your students. After you finish that discussion, the mechanics of the test can be undertaken. We end up with a Pearson's chi-square test statistic of 16.292 and a p-value fairly small of 0.001. So our conclusion, according to what we've done with our test of independence, is that the reported eye color and gender are dependent variables in the population of Stat 101 students at ISU. Students don't like this conclusion very much, and that's because they are definitely feeling that this conclusion contradicts what they know about gender and eye color. So biologically, gender and eye color are thought to be independent traits. And this was something new that I didn't realize until I did this research, that the genetic basis for eye color is not completely known. So we don't know which genes control eye color. Many of us learned that genes for eye color are a simple dominant recessive trait, but they're really not. And although it's very improbable, it is possible for two blue-eyed parents to produce a non-blue-eyed child, which goes against the dominant recessive trait paradigm. But what we do know is that the genes that we know their location that control eye color are not on the X or Y chromosome. And when they do these genetic studies of eye color, they don't find a dependence with gender. And so we're thought to be dealing with independent traits. So in our data, reported eye color and gender were found to be dependent. So the question is, why? Why would that be the case? Generally, when we discuss this with students struggled at first to come up with somewhat reasonable possibilities for this answer. So first, usually students will remark that there's a larger percentage of the females in the data, and so that must be why we're getting this weird result. And so we have to talk about, well, you know, conditional distribution, the chi-square test statistics, they all take this into account. And we could show you an example where the conditional distributions would be the same, and there'd be a more even split between the females and the males in the data, and we'd still end up with the same result. So this isn't, while this is one of the first things that they come up with, this just isn't possible as one of the reasons. Then when you're looking at inference, students will say, well, this was just bad luck. I just got an unusual sample. And of course, that's very possible, or it's possible, but it's probably not probable in terms of that. If you look back at the p-value of 0.001, so this would be a highly, highly unusual sample, and this helps us when we try to emphasize our the ideas of inference when we go back to that. So then we talk about some possible explanations in terms of what, in terms of this result. So the first possible explanation that we talk about is how we chose our eye colors and the options that we gave students. So when we talk about the genetic studies, we talk to them about the fact that they're classified using only the three colors, blue, brown, and then green, hazel. And while we can't determine what effect only having the four colors had on our data collection, we could estimate that by combining green hazel into one category. And when we do that, the Pearson's chi-square test statistic is smaller and the p-value is larger. We would still conclude a dependent relationship there, but our evidence of dependence is not quite as strong. So this is one possible explanation for why we're getting the results that we're getting. Another possible explanation is the use of student-reported eye colors. So when you look at genetic studies of eye color, they use expert opinion to classify the eye color into one of those three categories. In this survey, we asked the students to provide us with their eye color. And so the question is, well, are there differences in color perception among students that might be related to gender? And so one of the things that students automatically talk about is this idea of color blindness. Okay? In the literature, it's referred to as a color vision defect. And the most common is the red-green color vision defect. And so what that means is that people suffering from this defect are missing one class of photopigments, and that's either the medium class, which is in the greens, or the long class, which is in the reds. So they don't have any difficulty seeing the short class, which is in the blues. But their vision defects appears as the colors move from blue towards the red and green area of the spectrum. So this would mean that it would be difficult for these people to distinguish between green and hazel, and to distinguish between these colors and blue. And so why could this be a possible explanation? Well, as students know, and as we're probably familiar, the incidence of this type of color blindness is much more likely for males than for females. Approximately 8 to 10% of males are estimated to have this type of color blindness, where less than 1% of females are. This is a dominant recessive gene, and it is located on the X chromosome. And so since males only have one X, they're much more likely to have this defect than females. We had 919 males in our survey, and so using these percentages, we'd have somewhere around 80 of those males, give or take, that would be estimated to have this particular color vision defect. And it would look like from the nature of the color vision defect that these males could be more likely to over-report blue eye colors. The last possible explanation that we talk about with our students is that in our particular population of Stat 101 students at ISU, the distribution of the true eye colors between the genders could actually be different. While this seems like it would be the conclusion based on our statistical analysis, our data collection doesn't actually allow us to draw this conclusion. However, there could be unknown differences in racial and ethnic backgrounds of our female students compared to our male students in Stat 101 at ISU, and this would affect the distribution of the eye color as it varies according to racial and ethnic backgrounds. When you go through this and you talk with students about this, they realize, I think, and we make a point of talking about this, that we asked a very simple survey question: what is your eye color? And we've asked other, what we consider to be very simple survey questions that are not at all simple. So for example, our survey question had, how many brothers do you have? How many sisters do you have? That ends up being a very difficult question for students to answer. Do you only include your full siblings, half siblings, step siblings, etc.? The data collection methods that you use need to match your intended use. Our intended use was as examples that would be interesting to students. Genetic studies, their intended use is to find genetic patterns that would indicate which genes are in control of eye color. And so they must be much more careful about classifying eye colors than we were in this survey. However, our conclusions then must take into account that data collection method. So we concluded from our statistical analysis that these two variables are dependent. That doesn't mean, because of our data collection method, that there is a true difference in the distribution of eye colors between the two genders. So there are some extensions that you could be interested in doing with your students that are based on gender and eye color. The data could be collected, using just the three eye colors, blue, green, hazel, and brown. Okay. The data could also be collected in class. So this was a survey that students were sent off to do by themselves. If you collected the data in class, this would allow for outside corroboration of eye color by fellow students and could get them talking about how to classify eye colors. There is a data set from Census at School from Canada, and I believe it was from 2006 or 2007. And it was one of the data sets that I looked at when we were first coming up with this paper. And they collected eye color and gender as well, and there was no relationship between the two variables. So that might help determine whether the reported eye colors are a problem. You could also ask students or test for color vision defects. If you Google color vision defects and Google a test for those, there's lots of things on the computer that come up. And you could also ask students for their racial or ethnic background to see if there is a difference between the two genders with your students. And then finally, the last couple of semesters, we've asked students for ideas on new variables to collect. If you notice the variables that we had, some of those are out of date, like how many music CDs do you own? And so they were coming up with ideas about how many social media accounts do you belong to, which cell phone company do you use, which mobile operating system do you use, what type of cell phone do you have, some of those things that are more up to date in terms of current student life. So how long do you spend on your social media accounts per day, those types of questions. Okay, so that is the end of my presentation.
Well, thank you, Amy. I want to open it up now to questions. So again, if you have some questions, you can type them in the questions room, or you can certainly raise your hand and I can unmute you and you could talk to Amy. One comment came in while you were talking, Amy, and this referred to some earlier findings you were sharing, and the comment is, I actually saw these results with my boys. I have the dominant brown eyes and my husband has hazel eyes. Both boys have hazel eyes. So I thought that would be interesting to share with you.
Yeah, absolutely. Yeah, and we have that in my family. My mom has brown eyes, my dad has blue eyes, and both my brother and I have hazel eyes.
Oh, interesting.
Yeah, so it's very interesting how eye colors work, and so I thought that was very interesting when I looked at the research, because I always thought it was more dominant recessive, but it really isn't.
I had a couple of questions for you as we wait for other questions. I believe in one of your earlier slides that you said that this data was from either 2007 or 2009, around that time.
Yes.
Have you thought of collecting more data now and maybe seeing if things are different now that we're several years beyond those times?
Yes, absolutely. Yeah, and it would be easier for me to collect, or for other people if they wanted to collect data. With the learning management systems, it's really easy to create a survey. I know StatCrunch has survey options built inside that program as well. So it would be a lot easier to collect the data than it was for us. So yeah, we've definitely talked about that. That was part of the reason why I asked some of our current students to suggest variables that we could collect.
I was also kind of curious about something you said early on. I think you said that in the computing class you actually use this for data cleaning.
Right. So we have some interesting results on, for example, we have some data on the number of hours that they spent exercising.
Mm-hmm.
And some of the students answered a very large number.
Oh, yeah.
Yeah. Some of the heights are particularly different.
Mm-hmm.
So we had a female answer the height question was 44 inches.
Oh, gosh.
So, you know, we think that that maybe was supposed to be 4'4" or something like that. And so some of the one computing class that we have looked at this data as an example of how you might go about data cleaning.
Mm-hmm.
And, you know, do you keep these in? Do you leave those out? How do you, you know, how do you deal with imperfect data?
Okay, well, that sounds interesting.
Yeah, yeah. And those records are all in the data set that is available. So.
Oh, good, good.
Yeah, so you can play with those.
Well, are there other questions for Amy before we wrap things up? So it seems a little quiet today in terms of questions. We're all thinking about the end of our semesters or quarters and trying to prepare for that.
Absolutely.
Okay, well, I thank you again, Amy, for being with us today and for sharing this work. It was very interesting. I did want to make a quick announcement before we wrap things up. So we will not have a JSE webinar in May, and that's because ECOTS will be going on then. So we'll have our electronic conference on teaching statistics. If you haven't registered yet, you can do so by going to causeweb.org/ECOTS. So ECOTS will take place Monday, May 19th through Friday, May 23rd. We have a couple of great keynote speakers, Christine Franklin and Conrad Wolfram. And also there are 6 great 2-hour workshops that you can sign up for. So all the workshops run at different times, so if you wanted to, you could actually attend all of them. And some really great topics will be discussed during those workshops. So we hope you'll register for ECOTS. It's only $25, and you can stay at home in your pajamas and attend this great conference. So I will wrap things up then for today. Hopefully we'll have a JSE webinar again in June, and we will announce that as soon as that is set up. So thank you, everyone, and have a great afternoon.
Thanks, Michelle.
Thank you, Amy.